Alrighty, I will run through these pretty quick here, Maddie, I think. First thing I want to point out is down here on your, what is that, J, K, and L. Your first step here is just fantastic. Your radical is isolated. What we mean by that is you got your equal sign. On one side is just your radical. And everything in this side is under the radical, so you got to have it like that. If there's something that's not under the radical, subtract it or add it and move it to the other side. So get those radicals alone like these already were, and then do exactly what you did. Square both sides. The only thing I'd get after you for maybe is wrap that thing in parentheses, square that whole side. And that's what indicates, hey, I'm getting rid of this whole square root. I'm undoing that. Okay, so those are all started correct. We'll talk about how to finish them in a second. I'm going to run up here to C, though. And C, we'll attack it the same way you did those ones down there. The radical here is by itself on the left-hand side. That's great. And just like you did down there, you can just square both sides, and immediately the square root part, the radical part, just disappears. And you just keep everything that was under there still there. You've unsquared, or you squared the square root away. You've undone the square rooting. Okay? And on this side, you have to do that 6 times 6. Okay? And now it's just solve a regular equation. There's a couple ways to look at this one. I'll show you the way, one way you could do it. So like, this is the same problem. And so what some students think of it as is, hey, I'll divide this side by 2/3, right? It's 2/3 times x, so I'll just divide it by 2/3. I'll undo the multiplication. The problem is it doesn't work very nice when you try and do this side. Now there's ways to work around that, like 36 divided by 2/3. The way you work that is you go 36 divided by 2/3 is the same as 36 times. Remember, multiply by the reciprocal is how you do division with fractions. And so you could do this and go 36 times 3 is 108 and then divide by 2. Or you could divide by 2 first and go, well, this is 18. 2 goes into 36 18 times. Then 18 times 3 is 54. Okay, so that's one approach some students take. I take this approach. If I have a fraction and my x is on top like this, I say, hey, the reason this is hard is because it's divided by 3. So I usually multiply by 3 first and make the problem easier. Because now that it's 2x equals 108, I can just divide by 2 and get the 54 that way. Either way works. I like that second way I did there for better. All right, so now down to these problems. You've had your radical alone, you squared both sides, yada, yada, yada. We just got to solve this. This one's kind of interesting on how you could solve it. So I'm going to show you 2 ways to solve it. Way 1 would be to get it equal to 0. So I would subtract the 25, just like it looked like you were starting to. And then I got to solve this, and it is quadratic. So quadratics, we got 2 choices. You can either try to use the quadratic formula. This will always work. But, you know, it's not the easiest formula to plug into either. So I try to avoid that if I can. Or you could try to factor it to find out what x is. I'm going to factor it. If I were using this, here's my a. My a would be the 1 in front of the x squared. My b would be the negative 10 in front of the x. But my c would be a 0. So this, it wouldn't be too bad to use this to solve that quadratic. And I may do that here in just a second. But I would rather approach it with factoring and say, hey, does it have a GCF? And I can see an x. This one has x squared. This one has 1x in it. So I'd take out an x, leaving me x minus 10. And then I could solve that. I set each factor equal to 0. I get 2 answers. I get x is 0 or x is 10. Now, these are radical equations, so you do tend to have to check these. So if I put the 0 in, 0 squared minus 10 times 0, this would all come out to 0 plus 25. So the square root of 25, 5 is 5. So the 0 checks. Checking the 10's a little tougher. 10 squared is 100. Minus 10 times 10 would be 100. So that's 0 plus 25. Yeah, square root of 25 is 5. So that checks. Those are my answers. X is 0, x is 10. I'll do it over here with the quadratic. So I'll go negative of negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times, oh, c is 0. That's nice. Because if c is 0, 4 times 1 times 0, that whole term just turns to 0. So I can still put it over 2a here, 2 times 1. But my numerator just becomes positive 10 plus or minus the square root of Negative 10 squared is 100, and I don't have to worry about that red 0 up there, because that's just 100 plus 0. And look what I get. I get 10 plus 10. I want to do the plus sign first in general. So that's 20 divided by 2 still. There's one of my answers. And then I do the 10 minus 10, which is 0 over 2, which gives me 0. And you can see I get the same two answers I got over there. But way easier, I think, just by factoring it. But we'll see. You know, we never know with quadratics which way is going to be easier. Although in general, if it factors, that is easier. All right, so here's our next one, k, and you already squared both sides. Excellent. All I'm doing now is getting it equal to 0. And again, I'm going to see if I can factor it. No GCF. Now, here's my method for factoring. When there's a 2 out here, I go 2 times negative 9. And then I immediately write down 2x and 2x. One of these will simplify. And I'm looking for two numbers that multiply to that negative 18. But at the same time, the two numbers got to add up to the 17 in the middle. And right away in my head, I go, ooh, 1 times 18. Those two have a difference of 17. They got to multiply to an 18 and add up to 17. So I'll make the 1 the negative, and the 18 is positive, and then those two add up to equal a 17. So I know the two numbers that will give me this negative 18 and add up to the 17 in the middle. And so I put a negative 1 in one of them, an 18 in the other, and then I'd have to divide this one by 2. You always just look for either one or both binomials. You always check them both, but not always do both simplify. In this case, these were both divisible by 2, so I just do that and throw away that 2. These are not divisible by anything, so I just leave it that way. There we go, I got it factored. It equals 0, so now I use that 0 product property. Set the factor equal to 0 and solve it. X equals negative 4. So there's one way you could do it with factoring. Again, I do have to check these things. Let's check this half. Oh, that does not look fun. Let's check the negative 4 instead. So negative 4 squared is 16, and 2 times 16 is 32. So this left side would be like the square root of 32 plus 17 times negative 4 is negative 68. So minus 68. I'm not liking that at all. That gives me the square root of negative 34, and I can't square root negative numbers. So this one is not an answer. I'm going to check my half now. 2 times 1/2 squared plus 17 times a half. Now I got to still square root that 17 times a half like this. And I still got to square root that, and I got to see if that gives me that 3 on the right-hand side. So let's see here. This is 2 times a half times a half is a 4th right there. And so 2 times a 4th plus half of a 17 is 8.5. Let's see here, a 4th of 2, that'd be like 2 over 4, so that's like a half. 1/2 plus 8.5, oh, that adds up to 9. Oh, the square root of 9 is 3. It checks. So the half checked, but it looks like the negative 4 did not. Real quick, I'm going to do this with the quadratic formula because lots of students aren't good factors. All right, so don't be upset if you're like, oh, that factoring is so hard. Let me show you it with the quadratic. 2x squared plus 17x minus 9 equals 0. Here's my A, here's my B, here's my C. Negative of B, so 17. B squared, ooh, that's a big number. Minus 4 times A times C, all over 2 times A. Now, you wouldn't have to do this, right? Only if you couldn't factor it do you do this business. But here we're going to get a nice check. I can square 17. I think that's 289. Plus 72, if I do that math correctly. I'm just cranking through this thing slowly here. This is negative 17 plus or minus the square root of, I got to add these things here. 11, carry 1, 16. I don't think that feels right. I'm going to pull up my Desmos here and just check my 17 squared. I think that's 289. Yep, plus 72. 361. Can I square root 361? I hope so. Hey, look at that. The square root of 361 is 19. Thank goodness. I thought I had some mistake in here. So the square root of 361 is 19. Let's see. Now I do my plus 1. Negative 17 plus 9 is 2 over 4. That's a half. That was one of my answers. Then I do the minus 1. Negative 17 minus 19 is negative 36 divided by 4, which is negative 9. That wasn't the other answer I got. Negative 17 minus 19 is negative 36. That gives me negative 9, which makes me think I did screw this thing up. When I factored it, I think I put a negative 1. That should have been an 18 right there. Shoot it. Which gives me a 9 right here. There we go. So x equals negative 9. I better check that solution. So I'm going to check the x equals negative 9. 2 times negative 9 squared plus 17 times negative 9. 2 times 81 minus 17 times 9. Oh, that'll be plus 153. No, it won't. Minus 153. There it goes. That's 162 minus 153. Yeah. And that gives me a 9. Oh, that gives me a positive 9. Oh, then I have to square root it to see if it gives me a 3, because I'm checking that equation up there, and it does. So I got to go, fix that. I'll try to remind you of my text message to you. There we go. Good thing I did do it that other way. Yeah. X is a half or negative 9. X is a half or negative 9. Again, it better be consistent. And again, you don't have to do them both ways. Now, real quick, I could have also done this. If you got access to Desmos, when you get to, hey, this 2x squared minus 17x minus 9, you could just always graph that. And if the answers come out pretty and nice and clean, you could find them that way. So I've graphed that function. I'll make it a little bit easier to see. And I tap these zeros. Where does the y value equal 0, which is what this equation is saying? What's the x value that you can plug in to get a 0? And it turns out negative 9 gives me a 0 and 0.5, which is our half that we found. All right, so I could do it that way as well. 3 different ways to solve the same problem. And then finally, L here. Let's see, you got it equal to, you squared both sides. So now we'll bring the 16 over. It's quadratic, so you want it to equal 0. And I'm going to try my little fancy way, see if I can get it right this time. So A times C, I got to get a negative 18 again. So I want R times the S to give me a negative 18. But the R plus S has to give me the 7 that's in the middle. So 1 and 18 don't work. 2 and 9, they have a difference of 7. If I multiply them, I get 18. Now I got to get a negative 18. I want them to add up to positive 7, so I'll make the 2 the negative. Now these two add up and equal 7, but they multiply to negative 18. So again, you got to start with that 3. You go 3x and 3x. Put your minus 2 in one, put your 9 in the other. And then check both factors, 3 and 2. Neither of those is divisible by the same thing. 3 and 9, both divisible by 3. So you take that 3 out and toss it away. And so here's your factorization. And these are your solutions. Negative 3 and 3x minus 2. What makes you 0? 3x equals 2. Add 2 to both sides. Divide by 3. 2/3. So I think those are my 2 answers. 2/3 and negative 3. Now to save me time, I'm going to run up here and I'm going to just calculate this. I'll show you a fancy way to check it on your calculator. I'm going to give the left side of the equation the square root of 3x squared plus 7x plus 10. I gave it a name. I called it f of x. All right. And I think one of the answers is 2/3. So I'm going to type in f of 2/3 like this. And it better give me 0 out. And so I'm trying to get my division. There we go, 2/3. There we are. So if I plugged in 2/3, holy cow, that isn't right. It's giving me 4.864. It's supposed to give me exactly a 4. Let's check the -3 in there. -3 gave me undefined. This problem is not going well, right? Both of those should give me a 4. Let's see here. I'm going to check my factorization real quick. See, brought over the 6, giving you -6 right there. So that's 3x squared. That's 9 minus 2. That's 7. 2 times 3, -6. This thing's looking like it has no solutions, but that's not right. I don't think. Let's see here. There's my original equation, f of x. Oh, there it is. I forgot to put an x in. 3x squared plus 7x plus 10. There we go. And now I can ask it. F of 2/3. Does that give me a 4? Yes. And f of -3. Does that give me a 4? Yes, it does. So those are my two answers. Again, I could solve it with the quadratic formula if I needed to. And this side I didn't do. So we got to look at this side over here. Hopefully that gets you squared away on those. So this is like, when you saw me checking my answers, that's what this problem is. Which of the following solves this equation? So you could substitute in, use your calculator to help figure out, hey, if I put in -9/2 for x, does it give me a 2? Or we could just try and solve it real quick. So remember, the radical's got to be alone on the left side, and it's not. It's divided by that 2. So I'm going to go times 2 times 2 and undivide it by 2. 4x plus 19 equals a 4. Now the radical's alone, so I can square both sides, and the radical goes bye-bye. All right, so now it's 4x plus 19 equals just a 16. 4 squared. Nice linear equation here. Subtract 19. Divide by 4. So it looks to me like x is -3/4. Right? Absolute value, good alone. Check your possible solutions in the original equation. Reject any extraneous. So that's just telling you to check them. Hey, look at this one. Absolute values alone. This time it's on the right-hand side of the equation, but it's by itself, so we can just square both sides. Right? The right side I love. Those radical and the exponent knock each other out. The left side I don't love so much, because it says I got to take x minus 1 times itself. This should get you really your number b here. It works exactly the same way. I'm doing x times -1 now, -1x. -1 times this x, -1x. Maybe I put a 1 there so you can see it. And -1 times -1. So that's x squared minus 2x plus 1 has to equal x plus 11. All right, quadratic. So we got to get him equal to 0. So I got to move some stuff. Get rid of him. Line him up. Get rid of the 11. Line him up. X squared minus 3x's minus 10. 1 minus 11 equals 0. And now I hope I can factor him and solve him. This time I don't have to do a times c because my a is just 1, so 1 times 10 is still 10, or -10. Now they got to multiply to give me -10. I'm going to use a 2 and a 5 because 2 and 5 have a difference of 3. There we go. I'll make the 5 the negative, so you can see 2 times -5 gives me my -10, and this is 2x, this is -5x. They add up to -3. So there's my factorization, and I set each factor equal to 0. And those are my answers, but I have to check them. All right? And it says check in the original solution. Very important. So I'm going to check the -2. -2 minus 1. Do you equal question mark? The square root of -2 plus an 11. Let's see, left side -3. Right side is the square root of a 9. Uh-oh, square root of 9 is 3. That one didn't work. Wrong sign. Let's try the 5. 5 minus 1. Do you equal the square root of 5 plus 11? Question mark. 5 minus 1 is 4. 5 plus 11 is 16. The square root of 16 is 4. It does check. Oops, square root of 16 is 4. No more square root symbol. There we go. Square root of 16 is just a 4. 4 equals 4. There's your one answer that works. So hopefully you get the idea. Square both sides, right? 4x plus 36 equals, and you're going to have to square this binomial. You have to take it times itself and then get the whole equation. I just did this, then I do this. Oops, minus 12x. I do the inside, minus 12x. I do the negative 6 times negative 6. I'm writing really fast here because I got a class coming up and I'm trying to get it done fast. Sorry. Let's see here. Quadratic. Right there. So I got to get them equal to 0. This time I'm going to get the left side equal to 0. So I'll subtract the 4x. Line him up. I'll subtract the 36. Line him up. See, I'd end up with just 4x squareds on the right. I'd end up with a total of minus 28x's. 36 and negative 36 cancel, and I'm putting the 0 that was over here now on the right-hand side. I'm going to see if I can factor him. I see a GCF, right? 4 and 28 divisible by 4, and they both have x's in them. I grab each factor, and I set it equal to 0. And I get my answers. Divide by 4, add 7 to both sides. And then run them up and check them. Let's see, if I put in a 0, it'd be 4 times 0 is 0. So I'd end up with the square root of 36. Do u equal, plug in a 0 there, I get negative 6, and the answer is no. Square root of 36 is 6. So I cross out this 0. It didn't work. I'm going to check the 7 now. 4 times 7 is 28 plus 36. So that comes out to the square root of 25 plus 36 is like 61. Is that right? 4 times 28 and 36 is 64. Thank goodness. Square root of 64 is 8. Now I'll plug in that 7 over here, and that's 2 times 7 is 14 minus 6. It gives me 8 as well. So this guy checks, the other guy didn't. I said I wasn't going to solve that one, but I ended up doing it. Sorry. And let's see what directions are for 4 and, oops, there we go. For A and D here. Solve each of the following equations for all x. As in problem 1, be sure to isolate the square root expression first, square both sides. Check your solutions in the original, throw out any extra solutions, extraneous. So a little extra work on these. So, you know, here's my absolute value, or my radical. And that's what I want to be alone first. So who's next to him? I've got a 2. Let's highlight him, not cross him out. I got a 2 here that's multiplied by the radical, and I got this minus 8 that is subtracted. So I undo subtractions first. So I'm going to go plus 8 to both sides, giving me 6x plus 8. Can't combine them. They are not like terms. Still don't want that red 2 in front of it, so I'm going to have to divide this side by a 2, and this side times divide by 2. Okay, so there's that first step. The first step's a doozy, because it's get the radical alone, and now it is. There's the radical, and there's the equal sign, and so it's alone on the right-hand side. I just square both sides, boom and boom. Radical be gone. Left side, rats. Binomial be squared. Right, so I'm just doing what the math tells me. It says multiply those two. Multiply those. Multiply those, another 12x. Multiply 4 times 4. And there's my right-hand side again. Now this left side that I just multiplied, you can do a little cleanup, like terms there. There we go. Now I'm ready to start to solve it, and I go, oh, you're quadratic, so I better get you equal to 0. I can see some nice stuff happening here. 24 is going to knock out. So the left side, I get 9x squared minus 1. equals 0. And again, I could graph it and find out where do you cross the x-axis at, but I'm not going to. I'm going to try and factor this guy. This guy is a difference of squares. This is a 3x that's been squared minus a 1 that's been squared. It factors as 3x minus 1, 3x plus 1. The old difference of squares. This one gives me 1/3, and the second factor gives me negative 1/3. I'm just setting the factor equal to 0. I'm subtracting the 1 and dividing by the 3. That gives me that one, for example. Okay, now we got to check them again. Gosh darn it, way up here. I'll try and be a little more official with this check so you make sure you understand. 6 times, what am I checking? I'll check the 1/3. Just putting a 1/3 in there for x every time I see it. 1/3 of 6 is 2. On the right side here, I would multiply first inside there. Next, I would add inside the radical. Next, I would square root the radical, and I get a 10. And 10 does not equal 2 last I checked, so 1/3 should not be one of my answers. Interesting. Let's check the negative 1/3. 6 times negative 1/3. Does it equal 2 square root 24 times negative 1/3 plus 17? Left side this time gives me negative 2, and this is not going to work either. I'm going to graph this and check my work. Just come check it a little more creatively. I'm going to graph the left side. I'm going to graph the right side. Ah, 24x not equals 17 plus 17. And plus 24x plus 17. Got to have a 2 up front. That's not a very good looking 2. There's a 2, and then minus 8. There we go. There's my 2, my left side, my right side. I'm just curious, where do these two things cross at? Looks like they intersected right there. So 1/3 should work. So where'd my 1/3 go wrong? In other words, at 1/3, both the blue and the red one give me a 2 out. So 1/3 of 6 is 2. My 1/3 up here must have been scooped up. It's 2. 24 times 1/3 is 8. Oh, 8 plus 17. I forgot my minus 8 on it. Minus 8. I forgot this part. Minus 8, minus 8, minus 8, minus 8. 10 minus 8 is 2. It does check. So 1/3 checked, but the negative 1/3 is not going to. It comes out to 2, and you get the square root of a 9. It comes out to 2 times 3, which is 6. And that my minus 8, which I forgot before, should give me a negative 2, and it doesn't. It's supposed to give me this. Oh, it does give me negative 2. 6 minus 8 is negative 2. So let me check here. Supposedly at negative 2, these things cross again. So I'm going to, oh, look at that. When x is negative 2, they both give you a negative 1/3 for an output. No, when x is negative 1/3, they both give you a negative 2 output. So both of those work. The 1/3 checked and the negative 1/3 checks. So undo that. Okay. Last one I'll leave for you to do. I will give you this little hint on it, or a first step on it. You want to get rid of that 4 in the denominator. So you're going to take this side times 4 and this side times 4. And you'll get square root 6x plus 4 and square root minus 1 equals 4x. And so you're going to want that 1 to the other side first. Get the radical alone. And now you're ready to square both sides. Just make sure when you square that right side, you're going to have to write it twice, 4x plus 1 times 4x plus 1, and do all those distributions to figure out what it equals. Hopefully that helps you out, and I will stop